All right. So first of all, who remembers? Is this chemical or physical change? Remember this thing got real hot? Physical change. Then remember the concept there? I briefly explained it. What's in here? Anyone remember? It's called a supersaturated solution of sodium acetate. What does supersaturated sound like? What does that make you think of? What's saturated make you think of? Say anything that pops in your head. Saturated. What do you think? Wet. You think wet. With what? Water, right? Like if you got caught in a rainstorm, okay, and like torrential downpour and you're stuck, you would be soaked. Maybe saturated is another term someone might use. It's different but similar. See that white cloudy stuff in there? Pretty hard. That's called the sodium acetate. That's the solute. And there's so much solute in here. There's way more. There's actually water in here too. It doesn't appear to be any, but there is. There's so much solute that the solvent, the water, is like overtaken. It's saturated, but to the point where it's so saturated, it's called supersaturated. When you have too much solute, in other words, if you add a bunch of salt to water, it'll dissolve, but eventually you keep adding salt, it won't dissolve. That's kind of the concept. There's so much solute, it all can't dissolve right now. So what I have to do is put it in boiling water to get it to dissolve. But this is unique. Sodium acetate's cool because you can boil this in water, okay, inside, in the package here, so the water doesn't get in. And what happens is all this will dissolve again, and then it'll cool to room temp, and then it'll be dissolved. But it's a physical process. Some solutions, when they're created, get cold or hot. And this one, when the supersaturated solution starts to precipitate, when all the solute comes out of the water, it gives off heat. So again, it's a physical process because I can make it go back and forth. I can dissolve it, and then it'll do this. I can dissolve it, and then it depends on how I treat this. What's that called, giving off heat? Exothermic, right. So Bree, if this is really, really hot and I'm holding it, how does the energy move? From my hand to the hot pack, or from the hot pack to my hand? Hot pack to my hand. And what's that showing? The law of what? Conservation of energy, right. So I just wanted to kind of quick review that because I haven't fixed it yet. Back to this. Number one, talked about this last week. Who knows? In terms of forces of attraction, why heating a solid will eventually cause the solid to melt. Maybe I should go around and read somebody's. Max has an idea there. Right. He said, can I read it? He said the